Algebra 2, Chapter 9, Section 1, Quadratic Functions. A quadratic function is one that can be written in the form ax squared plus bx plus c, where a and b and c are constants and a is not 0. If a were 0, then we would have essentially a linear function. A quadratic expression in this form, ax squared plus bx plus c, is standard form. The term ax squared is the quadratic term, or also called the leading term. The constant a is the leading coefficient. The graph of a quadratic function with a positive a is a parabola that opens up. If the graph has a negative a, it opens down. The term bx is called the linear term, and c is called the constant term, which is also the y-intercept of the graph. In this case, c was positive because it intercepted a positive value of y. A quadratic expression can also be put into factored form by factoring. A quadratic function is in factored form when written as a times the quantity x minus r times the quantity x minus s. The number a, constant a, is the same number as in standard form. So we use a. Again, if it's positive, it opens up, negative opens down. R and s are the zeros of the function. These are the x-intercepts of the graph, or the place where the graph crosses the x-axis. Since the graph of a quadratic is a parabola, we have several different cases. We may have two zeros of the function, two places it touches the x-axis. We might just have one if r and s are the same number, which would happen when the quadratic is a perfect square. And we also have a case where there might be no zeros. The function may have no zeros. It may have no places that it touches the x-axis. If there are no zeros, then it is not possible to place the quadratic function in factored form. So it's not always possible to put a quadratic expression into factored form. We're not going to spend time in the videos reviewing factoring, but if you need review on factoring, go back and review the videos on Chapter 2, Section 3, Expanding and Factoring. There's a third form we can put quadratic functions into. This third form is known as vertex form, written as a, and here again a is the same number as standard form. The quantity x minus h all squared plus k. The point h comma k is the point of the vertex on the parabola of the graph. That is the graph of the function. So if we have this point 2, 1 as our vertex of a parabola, then we know that a must be positive since it opens up, and that the vertex, so in vertex form, if we were asked to give a possible formula, we could write a could be 1 x minus h, which is the x value, plus k, the y value. So this form has a negative in it, and it always can be tricky, so pay attention to that. The vertex is the maximum or minimum of the parabola. So in the case where it opens up, it's a minimum. In the case where the parabola opens down, it's a maximum. It's the biggest value that the parabola can take on. And you'll have some word problems in your homework that ask you to find a maximum or a minimum. And in such cases, you'll need to put the parabola into vertex form to find the point that is the maximum in this case, or the minimum in this case. And a simple way to remember the formula for vertex form is that it's simply a power function, a quadratic power function, ax squared, shifted right by h units and up by k units. So our material on shifting and scaling can be helpful to remember how to put vertex form, to recognize the vertex form. So let's practice with these different forms. The word problem. The height of a ball in feet thrown upward from the top of a building after t seconds is given by the following quadratic equation in each of the three forms. And we want to assume t is not negative because we're talking about time we did something. So we have a building. Okay, there's a person up here, and they throw a ball up. And watch, and then we can measure the height above the ground of this ball. The height is wherever the ball happens to be at that point in time. So we have 4 questions. The first one is, what is the height of the building? Assuming that we throw it from the very tip top of the building. So that's not said here, but just assume the person is laying flat and they're going to throw it straight up from the very top of the building without standing up and adding the height of the person as well. So the height of the building would be the height at time 0, which would be the y-intercept. When we put 0 into the function, remember these go away, we're left with just c, the constant term, the y-intercept, 128 feet. When does the ball hit the ground? That would happen when the output is 0, which is when the graph touches the output axis, if we were to graph this, which would be a 0 point. So when t is -2, we get a 0. That's not interesting because t has to be positive or 0. But here, when t is 4, we have 4 minus 4 is 0. So 4 seconds, the ball hits the ground. What is the height, the highest the ball goes? So we're throwing it up. What's the maximum? This is asking what's the maximum of the height, or the output. Well, that'll happen at the vertex. So if we were to graph this, we have a -a. We have not allowed to put in 0. What we started at 128 feet. We're going to touch 4 seconds, time, height. So we want to know what is the highest the ball reaches. Well, that'll be the output at this input, which is the vertex point. Now we can see from the vertex form, the vertex point's 144. So that happens at 1 second, 144 feet of height. So the highest the ball goes is 144 feet. And when is the ball at its highest is at 1 second, corresponding with the 1 in the input part of the point. So 1 second after we throw the ball up, it's at its maximum height.